Hello everyone, I am back with my new video with today's chapter atomic structure. Okay, let us first recapitulate everything fastly. First comes Thomson's atomic model, which we studied about. J.J. Thomson discovered electrons with the help of cathode ray experiment, and Goldstein discovered protons with the help of anode ray experiment. Both the setups were same, just they interchanged the plates. Then we studied about the mass of electron, proton and neutron. Mass of electron is 9.1 into 10 to the power minus 31 kg. Then comes mass of proton, that is 1.672 or 1.673 into 10 to the power minus 27 kg. Then comes mass of neutron, it is slightly higher than mass of proton, and that is 1.675 into 10 to the power minus 27 kg. So if anyone asks between proton and neutron which one is heavier, so answer is neutron is always heavier. It is slightly heavier, but yes, it is heavier. Then we also talked about charge and specific charge. Charge of electron is basically minus 1.6 into 10 to the power minus 19 coulomb. Then charge of proton is positive 1.6 into 10 to the power minus 19 coulomb. Then specific charge is basically charge upon mass. Okay, like let us say specific charge of proton, it is basically charge upon mass. Charge is 1.6 into 10 to the power minus 19 coulomb divided by mass is 1.673 into 10 to the power minus 27 kg. It comes near about 9.5 into 10 to the power 7 coulomb per kg. Okay, then we talked about important definitions and how to calculate the percentage change in mass. Okay, its formula is final mass minus initial mass divided by initial mass into 100%. Okay, that's how percentage change is calculated. If it comes in positive, then it shows that there is increase, and if it comes as negative, then it shows that the mass has decreased. Okay, important definitions has basically six definitions we talked about. First is isotopes, same atomic number and same elements. Okay, isotopes are basically those same elements having same atomic number but different mass number. Then then comes iso electrons and isoneutrons, isodiphers, isosters, isobars. Okay, we have talked about it. For an example, isobar is different elements having same mass number. Isodiphers are basically different elements having the same common difference of neutron minus proton. Isosters are basically different elements or can say compounds also having same number of atoms as well as same number of electrons in them. Isoelectrons are basically different elements having same number of electrons. Isoneutrons elements are basically different elements having same number of neutrons. Okay, isoelectronic can also have molecules, ions, etc., not necessary to be elements only. Then next we talked about Rutherford's atomic model. Basically he did the alpha scattering experiment and proved that most of the part of the atom is empty, or can say he made conclusions. Most of the part of the atom is empty, and mass is concentrated at its center. Atom's mass is concentrated at its center, so he named it as nucleus. Then there were some applications given by the Rutherford. Okay, first of them is radius of atom is equal to 10 to the power 5 times the radius of nucleus. Second is the combinations, or can say equation between volume. Volume of atom is 10 to the power 15 times the volume of nucleus. Third, he said about his radius of nucleus is equal to R naught a cube root, or R naught here is a constant term. It is also called Rutherford's constant. Its value is 1.33 into 10 to the power minus 15, okay, meter. Then he talked about the density. Density of the nucleus is always constant. Okay, and D is equal to, or basically density is equal to 3 by 4 pi R naught cube. Okay, and it is always constant for all the atoms. Then there were attraction forces on the nucleus from the there were attraction forces on the electrons from the nucleus and centrifugal forces also acting on it from the outside region. So both cancel each other, so therefore it nullifies each other. Now there were some drawbacks of Rutherford's application. He was unable to explain about the stability of atom, since electrons are revolving around the nucleus, so they must be revolving with a particular charge, but he was not able to, and also when they are rotating revolving around the nucleus, then they must lose some charge after every single rotation. But so at some point of time they must go in a spiral way and then collapse in the nucleus. But we all know that atom is stable, okay, and electrons rotate in revolve around the nucleus with a specific charge. So this was drawback of Rutherford's model and he was unable to explain it. Now next topic comes is electromagnetic waves. Electromagnetic waves are basically the energy transmitted from one body to another body in the form of waves are known as electromagnetic waves. They travel with the speed of light, okay, and they do not require any medium to travel. Speed of light is basically 3 into 10 to the power 8 meter per second. Now they consist of electric and magnetic field which are perpendicular to each other to the direction of propagation, okay, and their examples are infrared rays, ultraviolet rays, microwaves, etc. Okay. Now we will talk about characteristics of waves. As we all know, wave is formed by crest and troughs, okay. So let us see and visualize everything clearly. I have made notes which will help you, okay. See, this is basically crest of two waves and troughs of two waves, okay. First thing is wavelength. It is represented by lambda. Wavelength is the distance between two nearest crests or two nearest troughs, okay. See here, distance between two nearest crest or two nearest trough, and 1 angstrom is equal to 10 to the power minus 10 meter or 10 to the power minus 8 centimeter. I have written this because we are going to use angstrom in many of the applications and for solving numericals. Second thing comes is frequency. It is denoted by V symbol or known as nu, okay. It is not nu, nu, it is nu. Frequency is basically number of waves passed through a point in 1 second. Basically you don't have to remember the definitions. The main thing is these equations which I am going to show you, which are marked with red outlines, okay. So nu equals 1 by t, okay. Frequency equals 1 by time and its unit is hertz or per second. Second inverse means per second. Now next thing comes is wave number or nu bar, okay. Same frequency of symbol and a bar over it. Number of waves present per unit length, and its formula is nu bar is equal to 1 by lambda. Lambda is basically the wavelength, okay, and its unit is per meter or per centimeter. Next comes is time period. It is basically the time taken by a wave to pass through a point. So t equals 1 by frequency, okay. Next comes velocity. Velocity is the distance travelled by wave in 1 second. We all know that speed is equal to distance by time. So speed here is, we can write it as c. Speed of light here is equal to distance can be written as wavelength by time taken, and we know that from here time taken is equal to 1 by frequency. So putting the value of t, we get as c is equal to lambda into frequency, or it can be written as c by frequency is equal to lambda. This one is an important equation, okay, because questions are generally asked from this related to these equations, okay. Then next comes is amplitude, okay. It is the height of the crest or depth of trough, okay, or basically from this point to this point, okay, it is the height. This is known as amplitude. Now let us solve this question first, okay. This will help you to get a better hold in it. Calculate the frequency of EM waves having wavelength 6000 angstrom and c is equal to 3 into 10 to the power minus 8 3 into 10 to the power 8 meter per second. So here we are given with the wavelength and also with the c. So we have to find the frequency. We will apply the formula lambda equals c by frequency. Okay, we are given with lambda. Okay, we have to find the frequency. So we will put the value simply, and also 1 angstrom is equal to 10 to the power minus 10 meter, I have already said. So see, this 1 is meter, so we have to convert this angstrom into meter also. That's why we have written into 10 to the power minus 10 meter. Frequency equals this by this. On calculating, we get value as 5 into 10 to the power 14 per second, or per second can also be written as 5 into 10 to the power 14 hertz. Okay. Now let's see one more question. Calculate the frequency of electromagnetic waves having wavelength equal to 50 nanometer. Here we are given with we know the value of c, and we are given with the lambda also. Okay, lambda is basically wavelength. So first we will convert this nanometer into meter, because see, this 3 into 10 to the power meter per second is here. So for calculation all the units must be same. Okay, so 1 nanometer is equal to 10 to the power minus 9 meter. So we have converted it like this. 50 nanometer is equal to 50 into 10 to the power minus 9 meter, or can write as 5 into 10 to the power minus 8 meter. Okay, so we will directly put the formula and then the values, and we get the value as 6 into 10 to the power 15 per second, or 6 into 10 to the power 15 hertz. Okay, that's all for today's. Thank you.